If you can imagine being a road construction worker, it's 5:46 in the morning, your shift is almost over, you're looking forward to going home to your family. You and 4 of your coworkers are standing in front of that truck, a 80,000-pound vehicle traveling 65 plus miles an hour. That driver has dozed off. Despite the radar board, the arrow board, the strobe lights, everything, and piles into that truck at 60 miles plus an hour, 80,000 pounds. Everybody got to go home that morning. That's what we do. That truck saved their lives. In our development of the TMA trucks over the years, we've applied as much technology to the trucks as we can, converting them from being a dumb truck to a smart truck. They are the last line of defense to save lives in work zones. The concept of having an unmanned TMA is something we've been playing with for some time. The ATMA truck stands for Autonomous Truck Mounted Attenuator. Basically, when folks are working on a work zone, this is the truck that was designed to protect their lives. The way it's stacked is a vehicle hits it and it all crumbles in.
The way it works is we actually developed a system which we call our multi-platform applicate kit. We have a vehicle control computer, and then we have actuators for the steering, the braking, and accelerator. And these are essentially motors, and they receive input from the vehicle computer. It tells it, for example, how much to turn the steering wheel, whether it turns the steering wheel left or right, how much to engage the brake or engage the accelerator. And then you have sensor inputs that come from, let's say, obstacle avoidance or the other GPS sensors and video that are used for automating the vehicle and giving it the autonomous capability. And essentially what you're going to see is the vehicle shifting into drive, which we see here on the digital display. And now the vehicle is steering itself. The brake and the gas pedal are being controlled because it's receiving position data from the leader vehicle. And we're essentially going to follow this vehicle in the path that it is traveling. In a leader-follower operation, the MPAC system actually uses a velocity, heading, and position data from the manned leader vehicle and transmits that data in packets of information to the unmanned follower vehicle in what we call ECROMs. And these ECROMs allow the follower vehicle to mimic the exact speed, heading, and direction of the follower vehicle. Where we differ from Google or Tesla is that we actually can install our kit into an existing vehicle. So we can essentially convert any standard human-driven vehicle into an unmanned system.
Something like an autonomous road crew vehicle that still has human oversight but can contribute in a huge way to reducing fatigue, reducing incidents, is going to be a really important step to not only making it easier for the public to accept autonomous vehicles, but also to help guide legislation on how we're going to regulate these machines.
I honestly see a bright future with a lot of unmanned ground vehicle applications for the commercial market.
As the infrastructure decays more and more road construction is needed, a lot of states are starting to recognize the value of these trucks.
We're basically pioneering this industry. We're making use of the latest cutting-edge technology to make work environments a safer place.
Every day we feel better and better about what we do, and that's the juice that keeps us going when we build these trucks.